Hey everyone, and welcome. Today we are pulling back the curtain on something that's absolutely critical, but honestly, pretty misunderstood. We're talking about software testing.
I mean, think about it. Every single app on your phone, every website you visit, it all relies on this hidden process. Whether you're ordering food or checking your bank account, you just expect it to work, right? But behind that smooth, seamless experience, there's a ton of work happening behind the scenes to make sure it doesn't all come crashing down. So, what is that process really? What does it actually take to make all this tech we rely on every single day secure and, just plain reliable? Well, we're about to break it all down.
Okay, first things first. We have to bust a really common myth. Because what most people imagine when they hear the words software testing, well, it's not even close to the full story.
Seriously, take a second. What's the first thing that pops into your head? Is it like some person in a cubicle just clicking buttons over and over again trying to break stuff? Be honest.
Yeah, if that's the picture in your mind, you are definitely not alone. That's the stereotype. But the reality? It's so much more strategic, so much more complex than that.
All right, so if it's not just about clicking buttons, what is it then? Let's get into the real process and break down the true definition and the full scope of what testing is all about. Okay, the two words you really need to focus on here are quality and risk. See, at its heart, testing isn't just about finding bugs. It's a proactive process. It's all about assessing quality and, crucially, reducing the risk of failure before that software ever gets to you.
And that whole clicking buttons part, that's just one tiny piece of this whole puzzle. Before anyone even runs a single test, there's all this critical work that has to happen. You've got planning, you've got designing the tests. And then after the tests are run, teams have to analyze everything to make some really important decisions about the product.
And here's something that might surprise you. A lot of testing happens before a single line of code is even executed. That's called static testing. It's like reviewing the architect's blueprints before you start building the house, catching problems early. Now, dynamic testing, that's what we usually picture. That's the hands-on executing the software part. You absolutely need both. They're both essential.
Okay, to really get this stuff, you gotta speak the language. So let's learn a few key terms, the lingo that the pros use to talk about what's happening under the hood. This is so important. It's basically the cause and effect chain for any software problem. It all starts with a person making an error, just a human mistake. That little mistake then creates a defect in the code, what we usually call a bug. And then, if that bug gets triggered while the software is running, it can cause a failure. That's the part you see. The app crashing, the wrong number showing up, that kind of thing. All right, you hear these two thrown around all the time, right? QA and QC. And people use them like they're the same thing, but they're not. Quality assurance, QA, is all about preventing defects by making the whole process better. Quality control, QC, is about finding defects in the finished product. The assembly line analogy is perfect. QA is making sure the assembly line is designed perfectly, and QC is the person at the end inspecting the car before it leaves the factory.
Okay, this might be my favorite distinction because it's just so simple and powerful. It comes down to two questions. Verification asks, are we building the product right? Does it meet all the technical specs? But validation asks a way more important question. Are we building the right product? Does this thing actually solve the user's problem? Because you can perfectly engineer the wrong thing, and that's a massive failure that testing is there to prevent.
So why do we care about all this? Why does it matter so much? Because when software breaks out in the real world, the stakes are incredibly high. The consequences can go from just being annoying to being, well, absolutely catastrophic. $200 million. Just let that sink in. That is a staggering amount of money. What on earth could cost that much? The answer? A single software bug.
And this is the story behind that number. It's a famous and, frankly, tragic example. NASA's Mars Climate Orbiter. One team built software using good old imperial units, feet and pounds. The orbiter's software? It was expecting metric. That one simple conversion error sent a multi-million-dollar spacecraft into the Martian atmosphere at the wrong angle, where it just burned up. A total loss, all from one tiny, preventable software defect.
And that story perfectly illustrates a core economic truth in software. The longer a bug stays hidden, the more expensive it is to fix. I mean, it skyrockets. A bug you catch way back in the design phase, super cheap and easy to fix. But that exact same bug, if it's found by a customer after the product is already out there, it can cost an absolute fortune in support, patches, and damage to your reputation. So when you think about those kinds of high stakes, the real goals of testing become super clear, right? It's about preventing defects from ever happening. It's about finding the ones that do slip through. It's about gaining confidence in the quality of the product. And, maybe most importantly, it's about giving the people in charge the information they need to decide, is this thing ready to go out into the world?
Now, over decades, the testing community has developed this set of guiding principles. It's kind of like their collective wisdom. So let's walk through the 7 core rules that really shape how the pros do their jobs.
Okay, the first 3 really lay the groundwork. Principle 1, test early. We just talked about this, right? The earlier you find a problem, the cheaper and easier it is to fix. Simple. Principle 2, testing shows that defects are present. This is subtle but crucial. Testing can prove a bug exists, but it can never prove that there are no bugs left. You can't prove a negative. And principle 3, exhaustive testing is impossible. You just can't test everything. Even a simple login box has like infinite possible inputs. So good testing is always about making smart choices about what's most important to test.
Now this one is really fascinating. It turns out that bugs, they like to hang out together. They cluster. It's basically the 80-20 rule in action. Something like 80% of the defects are usually found in just 20% of the code. So knowing this lets testers focus their energy where it's going to have the biggest impact, instead of spreading themselves too thin.
All right, principle 5 has a great name, the pesticide paradox. And the analogy is perfect. Think about it. If a farmer sprays the same pesticide on a field over and over, what happens? The bugs that survive are the ones that are resistant. Well, it's the same with software tests. If you run the exact same tests again and again, you'll eventually stop finding new bugs with them. Your tests have to evolve just like the software itself if you want them to stay effective.
Okay, the last 2 principles really tie everything together. Number 6 is that testing is context dependent. This just means you don't test everything the same way. How you test a life support system in a hospital is going to be completely different from how you test a fun little mobile game, right? And finally, number 7 brings us all the way back to the beginning. The absence of errors is not enough. You could have a product with 0 bugs that's still completely useless because nobody wants it or doesn't solve their problem. True quality is all about building the right product for the user.
So this leaves us with one last big question. If we know testing can't prove that software is perfect, then what does it actually promise? What's the point? And the answer isn't perfection. It's confidence. Confidence for the business that they're releasing a solid product, and confidence for all of us, the users, that the technology we rely on every day is as safe and reliable as it can possibly be.